Assalamu alaikum and welcome everyone. Welcome to the complete solution of calculus session. In this session, we'll discuss problem from chapter 0.1 and topics are problems 9 to 10, and we'll solve here problem 9A, C, and E, inshallah. Okay, so let's have a look at the problem first. So here, this is basically pre-calculus item topics, and exercise is asking find the natural domain and determine the range of each function. Then, okay, so if you have the graphing utility, you can confirm your result by consistent or produce your graph. What is natural domain? First of all, you need to know and the range of this function. Okay. So natural domain is a set of real number for which the function f of x is defined. Here the function domain is not explicitly given. That's why we will consider real number only, and then output must be a real number. So set of all inputs or x values, we can call it domain, natural domain, and the output corresponding output is the set of range. Okay, we'll solve the first simple one, exercise 9A, chapter 0.1. Given f of x is equal to 1 by x minus 3. So let's recheck this problem. Okay, this is nice. Thank you. So basically, this is a mapping from the set real number to set R, and in this case, we'll find the domain F, natural domain, which you can define. This is the set of all x in R, such that f of x is defined. So basically, there are three steps if we to find the domain of a function. First, we consider all real number. If there is a denominator, then we must consider that denominator cannot be zero. And thirdly, if there is a radical expression square root, then expression under the square root cannot be negative. Negative will come on this later. So here f of x is defined always if x minus 3 is not equal to 0. That means x is not equal to 3. So we can write this in set notation, minus infinity to 3 union 3 to plus infinity. If I draw the graph for this domain, so if this is 3, this 3 is not included. Apart from this 3, all these numbers are included. So we know this is a real line, and real lines start from minus infinity to plus infinity. I hope this makes sense. Now, this is the functions. We need to find the range. Range is here, set of all y such that y comes from the formula for all x in the domain of f. So to get this, we need the function to solve for y. Let y is equal to 1 by x minus 3, and this implies then we have x minus 3 equals to 1 by y, and therefore we have x equals to 1 by y plus 3. So clearly we can see that clearly y cannot be 0. So based on these definitions, range is set of all y's such that y cannot be equal to 0, and we can write this in interval notation minus infinity to 0, union 0 to plus. I hope this should help. Okay, next problem. We move to the next problem. আমরা পরের প্রবলেমে যাচ্ছি। So let us see the problem 9c. 9c is root over g of x is root over x squared minus 3. Given function is g of x is equal to root over x squared minus 3. So here g is again it's a mapping from the set R to R. There's a real value function of real variable. Now we need to find the domain of this function. So what is the domain of g is set of all real x such that g of x is defined. Now here, this expression is also the even root of an expression. This is known as radical, and under this square root, this term is called radicand. So we need to be very careful when this type of expression, that the radicand cannot be a negative. So if g of x is defined, need to be defined, then this expression x squared minus 3 must be greater or equal 0. And then we can solve it for x squared must be greater or equal 3. So which means hello. ওয়ালাইকুম আসসালাম। এটা আছে আলহামদুলিল্লাহ জি। ও হ্যাঁ, একটা মেল পাইছি কালকে। আচ্ছা, 5টা থেকে শুরু না প্রোগ্রাম কাজছে? ওকে, থ্যাংক ইউ। So when x square is greater than 3, that means if you solve square root this, then x must be so the square of the number must be greater than 3. So then x must be less than or equal to minus root 3, or x must be greater or equal to plus root over 3. So square of this number is always greater than 3. You can have a draw the diagram. So this could be minus root 3 and this could be plus root 3. So square of this less than this number greater than 3, including these two, and square of greater than root over 3 are always greater than 3. So in interval notation, we can write minus infinity to minus root over 3 union root over 3 to plus infinity. Now to find the range of this function g, we know it is set of all output y such that y comes from this formula. Here it is g of x, and for all x belongs to the domain f. So the thing is we already consider this is the radical expression and this domain will not give any negative values. So the minimum values would be here always 0. So this in this case y is always greater or equal 0 for radical expression. So domain is from 0 to infinity. I hope this is enough for this problem sessions, and now we'll do the last problem. We'll discuss the solution of the last problem here. Uh, Exercise 9E, chapter 0.1. And let's have a look at the problem here, which is 1 by 1 minus sine x, h of x. A given function is h of x equals to 1 by 1 minus sine x. So it's involved trigonometric expressions. Again, it's a real value function of real variable. So the domain of this function h is, again, we write the definition set of all x such that h of x is defined, and we can see that there is a denominator here. So by rules, the function will be defined if the denominator is not equal to 0, and therefore we get sine x is not equal to 1. So when the sine x is value is 1, we can see the sine x graph. If we see, it is this expression, so when pi by 2, it is again. So in general, you can write that. So x cannot be equal to 2 and half pi. So after 2 pi period is 2 pi sine x function. So 2n plus half into pi plus minus, where n is starting from 0, 1, 2, and blah blah. So x cannot be these values. So this is set of all x such that this cannot be equal to x cannot be except all these numbers. So like here, and even you go twice pi, so here as well a value, and so these values are not defined. Okay, so we have the domain set of all x such that x cannot be equal to these values. Now to find range, now we know sine x is greater or equal minus 1. It has the range plus 1, and then we can define, we can solve it for 1 minus sine x. So what would be 1 minus sine x? So we multiply this, then inequality sign will reverse, and then we add both sides, all sides 1, say it's 0. So that means we have 1 minus g of x. Sorry, this is the h of x. That means we have got h of x is greater than 0 and less than or equal to 2. So this is not h of x. H of x is 1 by this. So we need to just, so we have Okay, so we can now reverse this situation. So 1 by 1 minus sin x is now, so half is less than when you do the reciprocal, then the inequality sign change again. So we have this, and the one this value must be greater than or equal to half. So we cannot write this less than this. So we have that means so we have the range. So therefore range is h of x is a set of all y such that y is greater than or equal to half, and which you can write or the other way around in interval form up to infinity. I think this complete this session. Thank you watching for this video. Please subscribe our YouTube channel and follow us on Facebook and visit our website for to get update about our all exclusive ebooks and courses. Thank you so much.